All right, listen up. So the rumors are true. This is our last gathering as a group for grade 12. I feel. You guys should be proud of yourselves. It's a long trip. It's 5 months. It's a lot of work. And I do know, I think it's fair to say this is the most work that you've done for a course in your life.
Yeah.
I don't think it's even close. So be proud of that fact. Sometimes I think the purpose of this course isn't so much to teach you math as it is to prepare you for what your university courses may look like. Right? So just getting used to how much work that you actually have to do. Number two, just a couple of thoughts about tomorrow before we get into it. What can you bring into the exam tomorrow? Yeah, bring in for sure. Bring in a scientific calculator. Do not bring a graphing calculator in because that would be really rough. If you bring in a graphing calculator and I take it from you, then you have no calculator. Then you have no calculator. Yeah. Yeah, so it depends. So Mr. Kaminsky and I will be here early tomorrow. We have to organize the space. There's 90 of you writing. We got to spread you out. We got to put up dividers. Hopefully we can get everybody up and running by 8:30. So probably open the doors at 8:25. Yeah, well, it will be locked at the top of the stairs. And then when we're ready for you, we will unlock and then you'll come straight down. You'll find out when you get there, there's going to be like information sheets. They're called demographic forms. It will have your name already typed into them. And it will be alphabetical. So if you're getting a sense of where you're going to sit, you don't choose. You'll look for a form with your name on it. I will have my two classes relatively close to each other. Kaminsky will have his class close to them. But there's 90 of you, and you can figure what 90 people in the cafeteria will look like. Okay. So it will take a few moments to get going. Also, you can bring water. You can always bring water. If you want to bring something else to drink, the answer is I'm not going to stop you, but I am going to suggest you probably don't need it. You don't need the complication. You don't need to spill it on the exam. Those are sort of the fears. Water, of course. We're never going to say no to water. Okay. Just like if you're thinking of picking up like a latte or whatever else that you want to drink, I suggest maybe against it. And then try to eat before the exam. Don't eat during the exam because the truth is I'm not going to let you eat during the exam. I agree with you. You just need to focus on the exam, and those are just distractions. Well, exactly. Like I don't know. Are we good with that? Are there any questions about that sort of piece? Yeah. You can do whatever you want once you got the exam. That's fine.
As long as it's not something like
Right. You can't bring in something that you've already created prior to. Once you sit down. Yeah. You do whatever you like. Whatever you like. Are we good to there? All right, let's get started then.
Yeah, exactly.
This is where we ended on Friday, so this is 36. It feels like this should be worth more marks. You guys can help me out with this as well. I think the piece that lots of people missed when they did this particular question is there a removal? And if there is a removal, what does that suggest? There's a POD. So there is a POD at x is equal to 0. Could we find the corresponding y coordinate of the POD now? Yeah, it's going to be, and I'm glad that you said that, because it would be like, even though the 2x's cancel, the minus sign is still in play. So it's minus bracket 1 bracket minus 3. Can you see this is the nature when we decide to try and find the y value of the POD? So this looks like to me, this is going to be positive 3. I think it's always good to state the coordinates of the POD. So 0, 3. Are we okay to there? Okay, and depending too, because sometimes they like to ask domain and range. I think you'll always get the domain right. It's the range that sometimes gets you. Okay. What else do we notice about this function? Oh, what does it look like after we've canceled it? Yeah, so what type of, oh, I got to be careful with how I wrote this.
Okay.
It is definitely now a quadratic function, but be careful, this minus sign is still in play, is it not? All right, I like what Thomas is saying. We know there's zeros here. We know there's a 0 at -1. We know there's a 0 at +3, and there's a hole at 0, 3. Okay. And then truth be told, you don't really need to find the vertex. It doesn't ask you for the vertex. Like you could find the vertex, but we're going to just draw it this way if this is okay. So it's a downward facing. Okay. Hopefully yours looks better than mine, but something like that. Yeah, I guess not. You could find the vertex. What's the easiest way to find the vertex? Yeah, okay. I actually like what he said. We know that the vertex, we know this is 2 steps this way and 2 steps this way. So is it safe to say 1 is the X value of the vertex? Yep. Yeah, I'd rate the whole points. Okay. Yeah, and like I would be pretty specific. I would have like my POD and I would probably mark it as 0, 3 and put POD over top so there's no misunderstanding. Okay. All right. Yeah. And then here, if you're looking for the vertex, like I gotta admit, if I was writing this exam, and I'm gonna agree with Art, and like the vertex isn't hard to find. We know it happens at 1. So then the value at 1 would be, if we use this information, minus, if I put 1 in here, it's gonna be 1 + 1, which is 2. And then 1 - 3, which is -2. So that looks like to me that's +4. And I think I almost hit that value anyways, just out of habit. Okay. Yeah.
So like if we like have calculator answered and the non-calculator portion, it would be kind of cheating, right?
Yeah, that would be very bad.
I thought that we get.
Then you'd be cheating, and then I don't have to mark your exam.
Don't you get?
You can do whatever you want with a pencil, absolutely.
Sorry.
Yeah, absolutely, if you wanted to. But you're gonna find that the numbers are relatively small, so you don't need to.
But
Yeah.
don't you get your calculator for the non-calculator portion?
No.
You do, well, I thought you get both focus, but then you have 45.
Are you ready to listen one more time? Are you ready?
Wait, okay.
Listen. So listen, shh. Last time. At the beginning of the exam, you will have your calculator in booklet 1. After 45 minutes, you put your calculator on the floor. You still keep booklet 1. And then I will give you booklet 2. And you will keep both booklets for the remainder of the exam. And when you hand your exam in, when you're finished, you'll hand me booklet 1 and booklet 2. What happened to your calculator after 45 minutes?
It's gone, but do I have booklet 2? Well, I have my calculator.
I'll say it one more time. At the beginning of the exam, you will have your calculator and booklet 1.
Okay.
After 45 minutes have passed and you put the calculator on the floor, I give you booklet 2.
Okay. So we have 45, and even when we're done, we just keep on checking after 45.
You do whatever you want with your calculator for 45 minutes, I don't care.
Okay.
You can do your taxes if you want to. Okay, all right, are we good?
Yeah.
And you're gonna find, if you'll finish the calculator questions that definitely need one, probably in 20 to 25 minutes. So as long as you can do whatever you want with that calculator in the first 45 minutes.
But we have to wait until the 45 minutes is over until we get the next book.
That's correct.
So,
That you
yeah,
can't change.
Okay, so no matter what, the exam is 45 minutes long.
Sure, is that what you're focused?
No, I'm trying to like understand.
What is the class factor that after someone finished?
Doesn't matter, irrelevant. Next question. Okay. Interesting question. We're trying to find non-permissible values of theta, and then they made it a little bit more interesting too, because they gave it unrestricted domain. I think most of us can see right away there's going to be an issue here with sine theta. So we know that sine theta is not allowed to equal 0. So what are the angles where that happens? Pi is true. 0 is true. So you could start off and just go 0, pi, 2 pi, 3 pi, 4 pi, and so forth. How would we state this effectively then? I'm going to mark it wrong and I'm going to mark it right. Then I'm going to feel bad about it. But you said pi plus pi n. Yeah. So is it just safe to say it's just then theta is not supposed to equal pi n, where n is an element of the integers? Nope. It's the same as saying pi plus pi n. Okay, I'm not done the question, but Mr. Montaigne. You get nothing for this. I just wanted to show the pattern. Yeah, and then but they failed to recognize that the domain is the entire real number system. That's why they got the half mark. Say that again, Luke. Yeah, like all I'm looking for is this when describing the bottom, but I do recognize there's another person here that needs to be talked about. Yes, Toby. Yeah, and they will accept both. But I've only told you Z, so I'm expecting Z. I don't know who's marking this. That's the trouble. And we don't know, like different teachers, there are some room for interpretation. Okay. All right. The second piece here is make sure that we recognize and honor that cosecant theta by design. What is that known as? Oh, isn't that great news? So then it's the same issue, isn't it? So can we just move on with our lives then? No, saying it twice doesn't make it more correct. I think for me, like you need to recognize that this needs to be considered. I'm surprised that they used cosecant theta. I would have thought the test writers would have said secant theta. Say that one more time. You're saying to me, if it was secant theta here, so let's say this was secant theta, yeah, you'd still have to take secant theta to the side and recognize because it's a reciprocal, there's, yeah. Yeah. Or where cos theta is 0, yeah. Yeah. Any reciprocal function has issues. Yes. Yep. All right, next question. Can you create a rational function so that we are clear? What does a rational function look like? The original rational function was this guy, wasn't it? Like y equals x minus h plus k. That's like level 1 rational function. What makes a rational function is when the variable is in the bottom. This one is supposed to have a horizontal asymptote. So we've talked about this. To get a horizontal asymptote, what needs to be happening? Bottom heavy. Okay. And you do appreciate there's more than one possible solution to this. It also says you have a vertical asymptote at x is equal to 6. So I think for most of us, like the simplest solution to this is just y equals 1 over x minus 6. Don't make it more convoluted for your own joy. There's no reason why you could not write f of x. So that would be the same. If you rewrote it as the function is defined as 1 over x minus 6, that is also acceptable. Question. Yeah. All right, so here we go. What about if y equals x over x minus 6 like that? Then your horizontal asymptote is wrong. Now your horizontal asymptote's at 1. Because now it's same heavy. Now, if you decided to rewrite it, just because I know you like to do this stuff just to drive us crazy, what about if it was like y equals x divided by x squared, x squared. I'm not going to do it. I'll leave it in factored. X minus 6 times x plus 2. Is that a rational function? Does it have a horizontal asymptote of 0?
Yeah.
Yes. And does it have a vertical asymptote of positive 6? Yes. Do you score bonus points with the markers when you do that? No. Right. But you can, like, yeah, and it's true. We satisfied all of the conditions. Luke. You wrote what? Y equals what? Of course you did. And I'm assuming then 6 cubed is 216?
Yes.
And what did you put in the numerator? Oh, Jesus. Yeah, it's fine. It's bottom heavy, so it has, yeah, it's fine. It's fine. I like it. I'm not going to deny it. Okay. This is a great question. I'm not going to lie. I got this one wrong when I did it. Right? I'm not the only one that got it wrong. I would say 85% of the people that did this question got it wrong. Yes. Yeah, that's exactly right. And then their friends kill their friend that has the allergies. Yeah, it's perfect. Yeah. So it's like recognizing that, yeah, at its core, when you look at a function now, you have to love and accept the function for what it is, but you also have to appreciate that it has its own concerns. And I think when we look at this function, it's safe to say that x has to be greater than and equal to, well, positive 1, isn't it? Any other value, you're going to end up if you put 0 or -1 or -2. So it has a restricted domain. And maybe here we notice that x in the other function can eat anything at once. It's one of those functions. So x is an element of the reals. So then they ask us to do a composition, and it doesn't seem like it's too rough of a composition because it's going to be g of f of x. So I guess it's g of the square root of x minus 1. And then when we do the square of this, doesn't it just create x minus 1? Are we okay with that? Because it's going to be this. I'll write it just so we can see it. This is the input, and then g of x squares it. And I, like you, I was like, woo, it's a linear function. I feel pretty good about linear functions. And I went down here and I put down x minus 1. And I'm like, I can draw x minus 1 all day. It's got a y-intercept of 1, and then it goes up 1 over 1, up 1 over 1. And then I pulled out my little plastic ruler. There's nothing more exciting having a little plastic, like those 15-centimeter rulers. You know what they look like. And I drew it like this. Okay, so I'm losing 2 marks now. Right? So important that we get this straight. So this is it here. Better? See? I haven't had any donuts today, so we can't blame the donuts today. Okay. I better have my A game tomorrow, or it's going to be expensive. Okay. And then when I left it like this and I moved on to my next question, can you see the mistake that's being made? The domain is wrong. So when we go back, now some people, it's funny, people did weird stuff because I marked this question. Some people wrote the domain here. They said, but we recognize that x has to be greater than or equal to -1, but they still drew the entire line. Yeah, so you lost a mark for that. Are we okay with why the domain is restricted? And so when you draw this, you have to stop where x has to be greater than or equal to -1. Is it +1? Oh my goodness gracious. Better? Okay. Yes. And then, so now we're going to start from here. This is the correct answer. Are we clear?
So what did you get on the?
Last one, I think like 88 out of 90. No. Yeah, Luke.
The one, two, three, like to go square root of x minus one squared. And what it as that? That's still.
You might lose a half mark for not simplifying.
No, you're fine.
I think-
saw the example you.
Yeah, I think there's an implication that if it simplifies that you should. I kind of agree with what you say and what Luke says. Like, why simplify when it doesn't necessarily ask for it? The big thing is just recognizing that, just as well as Elizabeth said, just because you square something doesn't get rid of the initial function's concerns. So please be careful of that. When you're adding functions together, subtracting functions together, composing, the restriction stays. Okay. Next, Suzanne determined the following. Describe her error. Well, right away, like I haven't even done the math yet. I know that she's got the wrong sign because if we're in quadrant 2, is tan theta positive in quadrant 2? Negative.
Yeah.
Is that the only mistake that she's made?
Yeah, makes sense.
So like I know for me, when I see these questions, I just do them.
The one mark. One
Yeah, because we're only looking for one thing. Okay. So I see this here, so we're just not going to spend a lot of time on it, but it says theta is supposed to terminate in quadrant 2. We're only supposed to describe her error, which suggests that there's only one, doesn't it? And then if we look at it, if there's only one error and she said that it's positive, we could just simply say then tan theta is less than 0 in quadrant 2. Are we okay with that? And justify justify, you're allowed some latitude. It doesn't have to be like explain. Right? Isn't that what I just said? If I say tan theta is less than 0, is that the same as tan theta is negative?
Because there was a number. It's not.
Either is acceptable. If you just say tan theta is negative, or
What's the describe it?
well, describe, if you're not sure, you can always go to the beginning of the exam. It tells you, right? And if you're not sure, explain is the one where you're not allowed to use math notation to explain. They just ignore it. So it doesn't help you or hurt you.
Looking for certain.
Well, they're looking for words and not math notation.
Alright, but like certain.
Justify, you're allowed some latitude there as well. It's explain is the one that's the difficult one. I don't know. Next. It's a good one. So we're trying to take the function that we see, and then we're trying to sketch the square root of the function. So when you do this, please be careful. I'm going to remind you that the square root of 0 is 0. The square root of 1 is 1. And then again, can you see they gave you the 4? Why do you think they gave you the 4? Square root of that is 2. Now be careful. It's linear after this, isn't it? Yeah, because this thing's not increasing anymore. It's staying as 4. So when you draw this, make sure you've got the bubble that goes above. And make sure you have the bubble. Remember we talked about the blue zone? Make sure you have the bubble that you're above between 0 and 1. And then after that, it's still going to increase. And then once it hits here, it has to be linear and it needs the arrowhead as well. Okay, watch for that arrowhead. Yes.
Like for questions like this, always the square root of the y value.
That's correct. When I say square root of the function value, the y value.
That's what x is.
That's correct.
Because the thing is like.
No, I get it. I'm never asking you to do anything with the x values here. Yes. Good question is what.
Always white on.
Oh.
I like white people.
Okay, next. Yeah, it's weird. And it's weird too that this is one mark and they've given you an eternity to work with. So we're looking for, and you can just, it just asks you to state the angle. So we don't care what math you show us. We're looking for one thing and one thing only. It's telling you the point is 0 minus 1. So is this not 0 minus 1 right at the bottom of the unit circle? And you can see, like, maybe some of us would be saying, well, initially the answer could be 3 pi by 2. Doesn't that take us to the bottom? But then you recognize the domain is very specific, and is our angle within domain? No. So what do I do to this angle to put it in domain? Add 2 pi to it. So if I'm going to add 2 pi to it, it's just 3 pi by 2 plus 4 pi by 2. So the correct answer is 7 pi by 2. How you get the 7 pi by 2 is up to you. Magnus, if you want, you could just do this. There's nothing wrong with that because the instructions are very simple. It just says state. It's one mark. How you get the answer doesn't matter. However, use the space as you need to allow you to find the solution. No, it's interesting. This is one of those marking nuances. They tell you that what you're writing is the solution to theta. They've told you that. Now, I got to admit, if I'm writing this exam, I'm probably saying theta equals this. Just out of habit. No, not when it says it in those terms. But I think sometimes it's hard to tell when you're telling theta equals and when you're not. So I always do. Another 1 mark question. What's the difference between these two transformations? Yeah, I think in terms of, I would do it this way. If you take a look at g of x, and if you wrote g of x correctly, it should be f of hard bracket 3 x minus 2 when it's factored correctly. And this would then be a shift. And then if I'm going to keep going down this path, shift 2 units, and I better get this right, in the opposite direction of negative, so 2 units right. If I want to describe h of x as given is already factored. And when we look at this guy here, it looks to me then this is also a shift. But in this case, it's 6 units right. I do it just so it's easier for me to see. You don't have to have the hard bracket. That's just a style thing, not a requirement. And therefore, you could just say, therefore, the shifts are different. Or even better, different shifts. I would. You got a whole page to fill. I have this urge to try and fill it. I don't think so. Not the way that I've described it here, because I use the word right, and that suggests it has to be horizontal. Okay, good question, Arden.
And then you like whenever they're like referring to like stretches like a compression.
Yeah, so a stretch and a compression are the same person.
And so like they say like a compression of 2, is that that's for a compression of 2 horizontal? Is that the same thing as a stretch by factor? No.
I think careful. Just stick to the language that I've taught you.
Okay.
Next. So you're supposed to solve the following. Makes me nervous when I see this because it looks too straightforward, but we're supposed to solve the following. The first thing that you're going to remind yourself, because this does actually feel like grade 11, you isolate the radical. Right. And then you have to square both sides. And then right away, I want you to feel nervous because we understand that when you square both sides in an equation, it's not an ironclad way to solve something. I will remind you of this, right? Like, I think we appreciate that 5 is not the same as minus 5. However, if you choose to square both sides of an equation, Can you take something that's fundamentally untrue and suddenly make it true? That's why when you square both sides, you have to check. As we move forward, we end up getting 2x plus 5 is equal to 9. I feel pretty good about that. So 2x itself happens to be equal to 4. X could be then positive 2. Oh, it's just like when we choose to square both sides of an equation. And I think if we go back in time just quickly, let me change my eraser. I'll try a different number. Arden, what's your favorite number? Make it small.
Yeah.
Okay, so do we agree that 7 is not the same as minus 7? So initially, they're fundamentally not the same. And usually when we do algebra, but the problem is that when you square both sides of an equation, you can take something that's fundamentally untrue, and then all of a sudden it is true. That's why when you square both sides, you should feel nervous, because sometimes you create extraneous solutions. Yeah. No. So all I want you, this is a good conversation. It's just that because you chose to square both sides, you should feel nervous because it's possible the solution that you found isn't actually a solution. The plus minus thing that you're talking about is different. If I said to you, hey, x squared is equal to 9, right? And then when I choose to take the square root, this is true for plus or minus, and this would be 3. That's different. Right, and then here, describe, well, so here we should check, and I bet you there was probably a mark for the check. If you check this, it's going to be 2 times 2 plus 5 minus 3. Does that equal 0? Does the square root of 9 minus 3 equal 0? 3 minus 3 does equal 0. So the root is fine, the value is fine. Oh, so yeah, and use the marks.
But if it didn't equal 0, we would say.
Well, if it doesn't work, you just put an X through it. It's just an extraneous root. Good question. I got to admit, I would probably just check it. You have time. Describe how the solution relates to this. So this is interesting. They gave the original question was 2x plus 5 minus 3 is equal to 0. And then we figured out that x has to be equal to 2 for this to be true. How does it relate to the graph of this function? What does it represent? Which intercept? Perfect. Right? Like if you didn't know, you could just put it in. Like, so y equals, if you put 2 into this thing, and we just discovered this, doesn't this give you y is equal to 0? So it's giving you the coordinate 2, 0. And by definition, isn't the coordinate 2, 0 the x-intercept? I think they'd even accept it's a 0 of the function.
Or would they accept as a solution?
No. Like, just put the
x-intercept as a solution.
no, because it's a no. Okay, here we go. We are getting close to the end. Oh, it's a good one. It's a good one. I'm so glad that this is in here. All right, so polynomial function. Can you find the zeros of a polynomial function? So you are going to do this. Do we remember how we choose the values that we're going to test? So you could try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. All of those are based on the factors of the constant, right? And then I said this usually happens pretty quick. So we're going to try this. I'm looking at the numbers right now. I have no clue which one's going to work, so I'm just going to try P of 1. So you just take your time, please, when you get this question. No calculator available to you. So this is 1 minus 2 minus 9 plus 18. We are close. And I'm going to say this is 19 minus 11. So therefore, just because I like this in the whole Maury Povich thing, but therefore, x minus 1 is not a factor. Now, do you have to show this work, honestly? No. Okay, what are we going to trust now? Just go to 2. You're tired of this show?
Yeah.
You know what? Maury Povich isn't on anymore anyway, so I can let go. Yeah. I'm not there yet.
Well, you have to use.
Oh, like synthetic to determine what you can. Yeah, there's no. So I heard there's a rumor going around that if you put 2 in, we get 0 out.
Yeah.
So it's 2 to the power of 3 minus 2. Yeah, I can see it. 2 to the power of 2 minus 9 times 2 plus 18. This is 2 to the power of 3 is 8 minus 8 minus 18 plus 18. And you guys will feel so much joy when you know that this is equal to 0, correct?
Yeah.
Therefore, x minus 2 is a factor. Are we good to there? Okay, let me get there.
So like the only time you change signs is when you put it into like.
Yes.
That's the only.
Yes.
So
Yes.
Change signs.
Yes. Okay.
I like making sure that.
No, that's a good question. And I'm doing it on purpose so we can remember this part, right? Okay. Now you're going to do synthetic division. So when you do synthetic division, you're going to build the penalty box. Do you remember that? And then you're going to remember you're going to take it from the perspective of the factor. And when you put the value into the penalty box, it feels shame because it's in the box. So you change its sign. So now it becomes plus 2. Then you will write down the coefficients. Make sure nobody is missing from the coefficients. So it's 1, it's minus 2, it's minus 9, and it's 18. Okay. So just the coefficients. If it's missing a variable, you need to put a dummy variable in or a placeholder variable. You need to put a 0 into that spot. Remember, the first number will drop, no change. And then the number below the line, I guess it was a blue line when we did it before, but the number below the line multiplied by the number in the box, that gives us 2. Then you'll add these 2 together. This creates 0. Multiply them to create 0. Add the 2 together to get minus 9. This looks really good now. 2 times minus 9 is minus 18. Make sure you put this division in here or this border in here. This gives you the remainder of 0. Okay. All right. This means the following is true. Your polynomial p of x can be described as this. The factor that you found, the x minus 2, and the pieces that you just found from the synthetic division. And I'm going to remind you who these pieces are. The number on the far right is the remainder. The next number is the constant. The next number is x. The next number is x squared. So when you write this in, this will be x squared minus 9. And then in the question, it actually asks you for the zeros of the function. So be careful. So now the polynomial is x minus 2 multiplied by x minus 3 multiplied by x plus 3. Have we stated the zeros of the function? It's factored, but we haven't stated the zeros. Therefore, the zeros, the magical values of x that make the polynomial 0 are x is equal to 2, 3, and minus 3. All right. 45. Bless you. Yeah. So what is the equation for every coordinate on the unit circle? Okay. That's the definition of a circle. I'll remind you, because sometimes they do this to you, like all circles are x minus h all squared plus y minus k all squared is equal to r squared. So remember, that's the definition for all circles. So sometimes they'll ask that. They'll say like the center, and center would be spelled like this. So center, let's make it a fun center. So 3 minus 4 is the center. And maybe they tell us the radius. What would be a fun radius? Too big. You should know this. Let's make the radius. Let's make the radius 5. Okay. So if I was asked to give the equation of the circle, it would be x minus 3 all squared plus y plus 4 all squared equals 25. That's it. If they ask for the equation of the circle, that's what it looks like. Yeah, I just made this stuff up. Everything in blue is me making up a question based on past experience. No. Okay. And then like Arton gave us the equation of the unit circle. I just gave you the equation for any circle. Right? This is the equation for any circle. We said, hey, let's have some fun. Let's make the center here. Let's make the radius here. And now this is the equation for the circle that's in blue. All right. If we follow through with this, we can do the following. We know the x value is the square root of 23 over 6, which we're shortly going to square, plus y squared, which we're kind of looking for y later, is equal to 1. If we move forward with this, this is just going to be 23 over 36 plus y squared is equal to 1. And now I kind of like it. Now I know why they said exact values, why they pluraled it. Are we okay with now at this stage in our career? When you have something squared, doesn't it always kind of suggest there's two answers when you have something squared? All right, moving forward, you get y squared is equal to, if it's okay with you, I'm not going to write it as 1 anymore. Can I just write it as 36 over 36 minus 23 over 36? And if that's the case, is that not just 13 over 36? Your value for y then is going to be plus or minus, we're nice to you, the square root of 13 over 36. Can we write it a little tidier? Plus or minus the square root of 13 just over 6. I don't know. It depends. Somebody might have an issue. Oh, sorry. Somebody might have an issue if you didn't recognize that. Okay. Good. It's 46. And this was the last question on the 2024 exam worth 1 mark, a whole page. 1 mark.
Yep.
Just don't make a mistake. Right. So we remember that tangent is simply the slope of the terminal arm. When I listen to my videos and I play them back, I'm like, man, he talks slowly. What is wrong with him? Okay.
It's called pi. No.
But, so the good news is, just so that we're clear, right? Tangent is the slope of the terminal arm. So the slope here at pi by 4, what's the tan value at pi by 4? 1. And then I think we're pretty good. What is it here? What's the slope of a horizontal line? So you could say x is equal to 0. That would work. Or, yeah, because that's where x is. I state the 0. The 0 of the function is the magical value of x that makes the function equal to 0. I heard somebody said pi. Pi works if x is equal to pi. That works. If you want to say x is equal to 2 pi, that works. You can see where I'm going. How many options do you have available to you? Yeah. Be careful, though. I think somebody had a bit of a snit because someone said, well, what if you just said x is equal to pi n, where n is an element of z? And I remember a certain person, not me. Sometimes it is me, but not me. had a snit about this particular answer because
It's more than that.
it's more than one. And the question says, at the end of the day, you just got to make a commitment.
Circle one.
Yeah, just or even better, like once you get done, it's like, you know what? I like this. Let's redact this guy. Let's redact this guy. Let's redact this guy. You're good. And honestly, because this is what Magnus is going to do, he's going to say x equals pi. Oh, do you see theta in this question?
No,
Are you introducing a variable that does not exist? That's a half mark deduction.
oh, yeah, yeah.
All right. I grabbed a couple other questions from the past. I grabbed this one. I don't know if we need this one so much. And you don't have to write anything down. Let's just sit back, relax. You guys have written enough this year. I grabbed this one. There's a couple others I want to look at too. So in this first question, it's asking you, could you do f times g of 0? So like in my mind, you could just start off, well, that's a nice f. Is that almost the perfect f? I think that's like the perfect f. I think so.
As a pause.
I think so.
Kind of looks like a G. There's too much touch on the,
Get it out of your system, it's fine. Wow. All right, well, I'll enjoy my moment, thanks. Okay. If you think of the number of times I've written the letter F at one point, mathematically, I'm going to generate the perfect F, right? All right, F of 0 multiplied by G of 0. How do we accomplish that task? Find where X is 0. So over here, I think this is where X is 0, but the function is -1. Over here, X is 0, but G is 2. And then all you'd have to do, because you have to know how to read the graphs, right? How to get dots from the graph. So here you're going to rewrite this as -1 multiplied by 2. Final answer is -2. Elizabeth.
That's effort. Say F of X times.
If you have one of these questions, you are never multiplying the moments of time together. You're only adding and subtracting the y values.
In any sort of form of chapter 10 set.
Yes. At no point are you adding x values. At no point are you subtracting x values. At no point are you multiplying x values. At no point are you dividing x values. You're working with the function values, which are the
Y value, because the function gives you the Y value.
That's
so the
correct.
function-
You decide what goes in, the function decide what comes out.
Oh, yeah.
It's like the claw, The claw decides from Toy Story.
Yeah.
Okay, all right. Next question, can you determine g of f of 4? Well, in order to do that, you need to find f of 4. So you go along function known as 4. You are traveling along. This is where you're at 1. This is 2. This is 3. This is 4. You put 4 into this function. What does it return? -1. So you're going to travel back over here, and f of 4, which we just discovered, is in fact -1. Then you're going to go to the function known as g, right? You're going to put -1 into g. So that means you're going to travel over here to where the -1 lives. And then you're going to find out that when you put -1 into this function, what does this function return? 3. Are we okay with that? So when you travel back over here, g of -1 is simply +3. Okay? But I'm glad that we're doing this because we needed to clarify this. Next up, tell me what time, that's what x is, what time does the first function equal 1? And please notice there may be more than one time it happens. So when does our first function here equal 1? It seems to me it happens here. It also happens here. So you could return with -3, or you could return with +2.
But you only need one.
I only want 1. Don't give me more than what I want. So you could simply come here and simply k is equal to -3 and move on with your life. Giving me more doesn't make it better. Okay. All right. So hold on. So every once in a while they ask this. It's a grade 11 question. I don't know why they do it. But if they ask you for the absolute value of X and they give you the graph, how do you graph this? And then make it worse. Make it worse. Explain.
Oh, no. Not even.
It's not even the first word. Like, it doesn't even say explain, then we know right away. This is like, given this graph, explain. So this is what happened, because this is what most people do, right? They see the graph, and I'm just as guilty. And I'm like, oh, I'm good. I got this. I got this. I got this. So we go to where there's no value, right? And then we just do the reflection, and then we just draw it like this. And I kind of go up like this and down like this. And I'm feeling pretty good with myself. And I'm like, good, done. Guess how many marks I earned? 0. What should I do? I use words.
Yeah.
I feel like, Magnus, which words shall I use? I feel like I should.
I feel like you should.
I do not graph it.
Changing negative by values to positive and then the actual positive by values.
I think I apply that when I use the word only.
Answer key.
Do you not know where to find the answer keys?
I know.
You have
Are they in Windows?
No.
Where they at?
If you check through our news feed, you know, the Facebook, the EDSB news feed.
Right.
And if you keep reading, I'll pin it, but there is a link to Assessment and Evaluation Manitoba.
Not a video, it's like a.
That's an actual answer key, a website.
Oh.
Oh, look at that. And then you just find the year and month, January or June, and you'll find. You'll be surprised what's in there.
It's a lot.
Okay.
They show like bad student things.
Yeah. Yeah.
Great,
The
okay.
student's not bad. It's the example.
Did they do them?
I got this vision of these bad, angry students doing math. Yeah. So we don't take off we don't take off marks for spelling. Okay. Like, I want to take marks off for spelling, but I'm not the one in control. Last one then. So I'm just going to make this one up on the fly just because I know it happens enough times for us to consider it. Try it again. I had this conversation with someone else earlier today too. Here we go. Why is it so thick? I don't know. Don't care. They like to do this. I don't know why they like to do this. They give you the sketch y equals f of x, and it's usually like a linear function. So let's make it a nice linear function like this. I don't know why this is so thick, but that's okay. Then they said, hey, you know what would be fun? Can you do g of x? But can you make g of x 1 over f of x? So I'm going to remind you this is in the grade 11 curriculum, but someone is fixated on this as not, or should be in the grade 12. All right, I'm going to remind you of where the original function is 1 and where the original function is -1. I'm going to remind you that when you do the reciprocal, these are like your anchor points. I would sketch this if you haven't sketched it, or watch this later. I'm going to remind you that where the original function is 0 is a problem for the reciprocal, because this is where the vertical asymptote must go. So you will be aware of this. This is the vertical asymptote must go where the original function happens to be 0. Okay. Is there a horizontal asymptote? The answer is there is one. What do you think the horizontal asymptote will be? Yeah, it's also here. So I don't know why they're fixated on this. And then I think we understand a little bit how this is supposed to work. When these values get bigger, this is reciprocal. So what's the reciprocal of 2? Hopefully you're saying a half. Reciprocal of 3 is a third. So you end up getting an arm that careens towards the asymptote here. And then you're going to get this racing away to positive infinity here. We also get the same thing on this side. So normally, if this is probably 2, you know this passes through 1/2. And then you get this here. So please be aware of reciprocal. I think we understand what reciprocal means. It's 1 over the original function. If it's obvious that like here, they'll do that too. Like if this is clearly at 2, then you can make this guy here pass through 1/2. Okay. Magnus. Only on your exam.
Well.
Yeah, I would. They don't give him the opportunity. Right? And then make sure you label this as the vertical asymptote. Y is equal to, I don't know what that number is, but whatever that number happens to be. Any other questions, comments, queries? Sorry. Good catch. So just so we're clear, this would not be y, it would be x is equal to, and I'm going to say this is 2, so x is equal to 2. What are we doing? Hold on. What are we doing tonight?
Dabble.
Honestly,
Resting.
you should not be studying tonight.
Yeah, that's what I'm saying.
No.
I
I know Lillian's like that.
Rest your brain.
Go for a walk, go play catch, go do some gardening. Do other stuff, like your brain is a muscle. Wrestling. You guys have done the work, right? Like we've been doing this for 5 months. See, I'm not kidding. Like I want you guys coming in fresh and ready to go. Right? Not exhausted because you're up till 3 in the morning trying to learn stuff. Don't do it. Don't do it. And I've seen that look, that sort of that zombie look when they walk in. Like, is that the way you want to be walking into an exam? Try to go to bed at a reasonable time. I don't know what that is. At 11 o'clock, is that sort of the reasonable teenager time?
So do you think study for 1 hour tonight would be good?
Yeah, like if you got home and you just kind of read lightly through your notes, like for an hour at most, that's fine. But if you're putting in 4 or 5 hours tonight, it's counterproductive.
Yeah, if you sort of that's let me know it's good. Like, is it okay? Look, yeah.
I'm pressed, I can do it when you want. It's just half hours speaking in the moment. I'm letting which like 1.5 of them. And then I'm. What time do you think?
Like, put it next to the put X axis, and then I'm gonna erase the X.
And you like. One that uses the back. So you think it's like controller. Yeah, I'll try.
Any combination of.
I mean, both can. Yeah. Yeah. I'm not the gym, not the gym.
This is one.
Yeah.
I'm not gonna watch that.
Take your X out and use.
Part of
Already the other way around.
Yeah.
January can start.
One of my planets just went by like, so you don't have to miss the part of me. Yeah. I'm doing the C part right now. I think. But those.
Here we go. One more.
Listen, what's your favorite donut?
Free. All right, here we go. Is that a good answer?
Yes.
Am I allowed that
I'm
answer?
gonna have like all free donut on your table.
A particular math class has a large number of students, and from this class, you're able to create a committee of 4 students that has at least 1 girl. Oh my God. Without actually solving the problem, explain, I agreed, the strategy you could use to find the total number of ways to select this committee. It's not that bad. Let me just grab this for a second. By the way, snipping tool, greatest tool ever created by mankind. Okay, copy.
Remember which book.
It doesn't matter. It's irrelevant. Here we go. If this is the question, they don't actually tell us the size of the math class, which is kind of a pain. And you're supposed to explain the strategy. So let's change the question a little bit. Let's say there's 20 students in the math class. Okay. So if we got 20 students in the math class, the other thing I want you to grab onto is I hate at least. I wish they just say a minimum of one girl. So you're supposed to build a committee of 4 students, right? And this would be cases. So here's the cases. The case 1 would be 1 girl on the committee. And if that's how we're going to work it, now we need more information, don't we? Because we're distinguishing between male and female. So maybe we'll say it's like we've got 10 boys and 10 girls, right? So if we've got 1 girl on the committee, we'd have to do it like this. There would be 10 ways to choose the single girl on the committee. And then what would we multiply it by to fill in the remaining spots? Choose 3. So that gives us the 3 boys that we need, right? And whatever that works out to be. Then we're going to do case number 2. Because it says minimum 1 girl, case 2 would be 2 girls, or exactly 2 girls. So when you do that, you have 10 girls to choose from to make 2, a group of 2, and then 10 to choose from to group a group of 2 as well. That gives you the boys and the girls. Case 3. So now you've got 3 girls to work with. I can already tell what. So in this case, it's going to be 10 choose 3 multiplied by 10 choose 1. Okay. So can you see that's now 3 girls on the committee and then 1 boy? And then what's the last possible case? Yeah, case 4 would be all girls or all 4 girls. In that case, it would be 10 choose 4. And then because they are cases, you always add cases together. Is there a faster way? Yeah, we could do it by converse. So this works. There's nothing wrong with this. You'd have 4 numbers and add it together. Or you could do this. You could do 20 choose 4, because what does 20 choose 4 represent? All possible groups regardless of gender. I just did this for my question. I just took the question over. I'll give you the explanation in a second. Minus, you could then simply take 10 choose 4. Conceptually, what does that represent? All boys. That means every remaining committee has to have at least 1 girl. And then I might do my explanation here. So I might just say, and maybe this is a good strategy, like this is the math. We are not giving you any credit for that. But then you could explain, if I find, I feel like, if I find all committees possible, regardless of gender, because that's what 20 choose 4 represents. And then subtract, I can't believe I'm writing the word subtract, but I am. Subtract the all boys committee. What should remain? Then all remaining committees must have at least 1 girl. Or you can say by converse, whatever language you prefer. Are we okay with that? Okay, so get some rest tonight. Make sure you have a good breakfast tomorrow morning before you come in. You can bring water, you can bring coffee, a little bit. Yeah. Well, when are you gonna come back for? Oh, can you come back for it? So I can think like, I don't want to do it super quick. Of course you can. Or you come back, I'm showing, you come back.
Yes.
Oh, let me come back. Hold on. Hold on. Like, no, like-